Hello friends, welcome to my channel. My name is Corrosion. So today we are going to start chemical reaction and equation part 2. So can we start? Let's go! So in previous video we already seen what is chemical equation, what is chemical reaction, but now we are going to learn what are the types of decomposition reaction. Means if you remember in previous video, means in part 1 we watched endothermic reaction, exothermic reaction and 4 types of chemical reaction. So the important type of chemical reaction, decomposition reaction, we already saw, but there are also subtypes of decomposition reaction. So this is the first topic of this part 2 video. So can we start? Let's start. So there are 3 subtypes of decomposition reaction, that is thermolysis, electrolysis, photolysis. And one important thing, the decomposition reaction is endothermic reaction. Got it? So let's start with thermolysis. Thermolysis, the word thermo, that we can say it is refer for heat. Means in this decomposition reaction, it is decomposes due to the heat, so it is called thermolysis. And then second is photolysis. Photo means sunlight. You know photosynthesis, so the meaning of photo is sunlight. So means any product or any reactant that decomposes by the sunlight, by the photo, it is known as photolysis. Got it? And the third type is electrolysis, means it is formed by electricity, electric current. For example, when we take, let's me zoom. For example, when we took water and we put anode and cathode, then it produces the electric current by battery and it decomposes a reactant into 2 or more products. Understood? These are the types of decomposition reaction. So let's see the example of thermolysis. The thermolysis example is, what are these? So the example of thermolysis is CaCO3, means calcium carbonate. When it is heated, then it forms CaO and the carbon dioxide. This is the example of thermolysis. And the example of photolysis is, for example, silver chloride, AgCl. It gives a grey color due to the sunlight and to form a silver metal. Yes, to separate the silver chloride, the photolysis takes place. Due to that, the silver metal separates. Understood? So let's move to the electrolysis. I already told that it is the oxygen, it is anode, cathode, it is the battery. By electricity, the reactant produces 2 or more products. This is the electrolysis. I hope you will understood the decomposition reaction and their subtypes. And the important thing is decomposition reactions are endothermic, means they supply the heat, they do not taken out the heat. Yes, let's move ahead. So what are these? Corrosion. First of all, the corrosion, after the means before the corrosion, we must take this oxidation and reduction. What is it? Let's me open. Redox reaction. Redox reaction. Lal bile? No, not at all. It is a redox reaction, means red means reduction and OX means oxidation. So what is oxidation reaction? The first reaction of redox reaction, we can also say oxidation reaction. Addition of oxygen, addition of O2 or removal of hydrogen, means addition of O2 or removal, means minus sign of H2, it is known as oxidation reaction. Understood? And reduction, removal of O2, means removal of oxygen and addition of hydrogen, this is known as reduction. And there is in other way, in hard way, we can also say electron, removal of electron, it is also known as oxidation reaction, or addition of electron, it is also known reduction reaction. But this is not basic, means this is not important. it is only the important is addition of oxygen or removal of oxygen, or the vice versa. This is important. The removal or addition of electron is on the basis of 11th 12th, so it's not important. Only you remember addition of oxygen or removal of hydrogen is known as oxidation, and removal of oxygen and addition of hydrogen, it is known as reduction. So let's move ahead. So site of what is it means in a reaction, what it is. So first of all, let's start this. Let's clear the concept. They take place simultaneously, means in a reaction both oxidation and reduction both take place. Means if it is get removed oxygen, it is known as reduction, but if oxygen is added, it is known as oxidation. So in reaction, when the oxidation is removed, automatically it also added to another thing. So we can say redox reaction, and in reaction oxidation and reduction both take place, so we called it redox reaction. I hope you will be understood or clear the concept. So let's move ahead. What are the reaction? So for example, the reaction is Cu plus O2 is equal to CuO. Means if when copper is added or reacted with oxygen, it produces copper oxide. So we need to find what are the site of oxidation and site of reduction. So site of oxidation means in which the oxygen is adding or hydrogen is removing or oxygen is adding, is known as oxidation, site of oxidation. So in Cu, in copper, the oxygen is adding, so we say site of oxidation. So site of reduction means in a particular area the oxygen is removing or hydrogen is adding, so we can say site of reduction. So in this, in oxygen place means in O2, the oxygen is removing, you are understood, the oxygen is removing and adding to Cu. So here the oxygen is removing, so we can say the site of reduction is O2. So what are the oxidizing agent and reducing agent? It is also easy, but it is a confusing complex. So oxidizing agent we called O2, because if O2 is neither there, then how does Cu get oxidized? Are you getting it? If oxygen O2 is neither, then how can Cu get oxidized? So O2 is oxidizing agent and reducing agent means Cu. Means if there is no Cu, if there is no copper, then how? Then how will oxygen is added? Means if there is copper, वहाँ पे कॉपर नहीं होता तो ऑक्सीजन कहाँ पे ऐड होता? सो इसलिए कॉपर इज ऑल्सो वी नोन एज reducing agent. Are you clear? Site of oxidation, site of reduction, oxidizing agent and reducing agent. I hope you will get clear and like it. So let's move ahead. So our favorite point and the last points are corrosion and rancidity. So let's start by corrosion. When metal surfaces are attacked by substances around it, such as oxygen, moisture, acids, etc., it is said as to corrode, and this process is called as corrosion. Means in a metal surfaces, if they are attacked by some substances like oxygen, moisture, etc., they will get corrode. Means they will be spoiled, damaged. So this process is known as corrosion. So for example, iron, we know, we are studying by lower classes. The corrosion of iron we known as rust. Only the corrosion of iron we know, yes, rust example. So in rust, in Fe, when it is reacted with oxygen, when it is reacted with H2O, means hydrogen, moisture, then it will be getted hydrated. Means when iron Fe reacted with O2 or H2O. It is getted into hydrated form. It is also known as hydrated iron oxide or hydrated ferric oxide. So this is an example of corrosion of iron. Let's move to other metal. The other metal is copper. Means when copper is reacted with O2 or copper is reacted with CO2. Sorry, when copper is reacted with CO2 or when copper is reacted with H2O, it get damaged, it get corrode. Means here the color, the green brownish color gets attacked on it copper. So this is known as corrosion of copper. And the third example is Ag, means silver. In silver, the blackish color comes by this by sulfur. By the element sulfur, the silver is damaged. Due to sulfur, the surfaces of silver is getting damaged, getting color into black. So this is the process of corrosion of silver. I hope you will understand the corrosion of iron, copper, and silver. So let's move ahead. So this is the process of oxidation. Means it is that corrosion is known as process of oxidation. Understood? It is also known as oxidation. Means due to oxidation, these all metals get corrode. So it is undesirable since it reduces strength and fades its appearance. So by oxidation, means by corrosion, what happens? The desiring structure of that metal get damaged. Understood? It is a bad thing. It is not good thing. It also gets the fade, means also damage the appearance as well as is also damaged. Also, for example, in iron, when it gets corrode, it also damages its appearance, it fades its appearance, but as well as it reduces its strength. Means it decreases its power, it reduces its strength. So it is not useful and it is undesirable. So we must be prevent the corrosion. So what are preventions of corrosion? So the preventions of corrosion are, for example, greasing, galvanization, ironing, oil paints, etc. These are many prevention for corrosion. So in detail we can take in the third chapter, metals and non-metals. So only in this chapter we must to remember there are some many processes of prevention from corrosion, that are greasing, galvanization, iron plating, oil plates, etc. So let's move ahead. What is rancidity? Yes, this is the last topic, means the theoretical last topic of this chapter. The rancidity. What is rancidity? The taste or odor of a food material containing fat, oil, changes when they are left exposed to air for a long time. Means, for example, chips packet or for example dry fruits, when they are kept for long time in atmosphere, in contact of air, so it gets damaged the odor, get damaged the taste. Means it contains fat, means the chips contain fat, oil, the dry fruits also contain oil, for example groundnut, kaju, badam, etc. So by rancidity, means when we keep for a long time, it get exposed, it get damage the taste, damage the odor. Are you getting it? So this is known as rancidity. So it is also a form of oxidation. We know corrosion is also form of oxidation and rancidity is also form of oxidation. Means it is caused due to oxidation. Are you getting? Yes. So prevention, what are preventions of rancidity? By adding antioxidants to the food material, storing food in an airtight container, or used flush bag of nitrogen gas. Yes, in chips bags or in any snacks namkeen bags, the nitrogen gas is flushed. In factories, in industries, the food industry, the nitrogen gas is flushed into the bag of that container, bag of that snacks. Due to that, it is act like an antioxidant. Means it is a less reactive and it prevents the reaction of that foods. So N2 is known as antioxidants and it is flushed in the wrapper bags. And for example, if we open the pack after purchasing it, we can also tied the food back, that we can prevent the rancidity. Are you getting it? So let's move ahead. So the another point is balancing chemical reaction. It is most important point of this chapter is balancing chemical equation. So let's start with it. So in part 1 we already learned that the law is it. So in reactant side and in product side, means in LHS and in RHS, the all equal atoms of element is equal, means we need to equal all the elements of both side. So this is known as balanced chemical equation. But sometimes or in even very casual times it is unbalanced, so we need to balance the chemical equation. For example, let's see an example. Example is Fe2O3 plus C is giving the product Fe plus CO2. Means when the ferric oxide reacts with carbon, it giving ferrous plus carbon dioxide. So here this is an equation, but here what we have, there are two atoms of iron, but in product side there is one atom of iron. Are you getting it? Yes. So we need to balance it. And here also there are three atoms of oxygen, but here there are two atoms of oxygen. And here is, but carbon is same because here is also one atom of carbon and here is also one atom of carbon. So what we need to balance? We need to balance the Fe and oxygen. So how to balance, I tell. So first of all, there is a rule. Rule is what? In initial position of reaction, we need to add the numbers. Means if there are 2, so we need to add 2 by these 2. There is 2 atoms of Fe and here also Fe2. By this it get elements balance. Are you understanding? This is the rule. We can't put here. We can't put at the end. We only put at the initial position. We only put at the initial position. This is the rule. Are you getting? And we can't reduce the number of this. Means if Fe have 2, we can't reduce by Fe1. So we only increase that. We only oxidize, means increase that. We can't reduce and we can't put the numbers at end. The rule is we must put the numbers at initial position and we must increase the values, not to decrease. Are you getting it? So let's start. So first of all, I took here 2 because to balance the Fe. But Fe is balanced, but there is one problem, that oxygen is not balanced. So there is 3 and here is 2. So when we get 3 here, it is impossible to get 3 here. So we need to increase more. So we need to get here 6. So we put here 6. Are you getting? 1 minute. So by this we can balance the chemical equation. So it is little hard, but the another idea is make a column. Means here write the reactant side, here write the product side, and write Fe, oxygen, carbon, and write the numbers here, and try to balance it. Try to practice. By this we can do perfect. So let's move ahead. Another example. Let's see a easy example. So the easy example is copper plus O2 is equal to copper oxide. So by this there is already balanced the Cu, but we need to balance the oxygen. So we put here 2. Understood? So copper get 2 and oxygen also get 2. So oxygen get balanced but copper get unbalanced. So we do here again 2. So by this we can get 2 copper plus oxygen is equal to 2 copper oxide. Understood? Let's move ahead. H2 plus O2, we get H2O. So we put here 2. Then hydrogen get 4. So we put here 2. It is very easy. Practice, practice, practice. Practice made man perfect. So I hope the chapter is very easy and you will get it and you will understand it. I hope you will understand it. So by these two videos, we finished our first chapter of chemistry, chemical reaction and equation. So this is the topper parts, means this video is for toppers only. And the another video we already made the 4 parts of this 6 months ago. This is the new, means this is the new offer of my channel. So I hope you will get it. If you understand and if you like my teaching, if you like my explanation of this chapter, so please like my video and subscribe to my channel. Subscribe कर देना यार. So bye bye. Let's see you again in next video. Bye bye.